Hello and welcome to the Daily Space for today, July 3rd, 2018. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. It's a kind of slow news day, but I think we have some stories that will, if nothing else, perhaps get you thinking. Our first story is less breaking news and more things that need to happen that came out as part of a press release. The National Academies of Science here in the United States are a independent body of scientists who work together to provide analysis, provide feedback, and sometimes provide policy suggestions to the various science agencies that are part of the U.S. federal government. These kinds of activities include everything from putting together the decadal survey, which serves as a guideline for how federal funds should be spent on science, to critiquing policies and programs that are currently in place to try and make sure that things go better and go more smoothly. Currently, the National Academy of Science has finished up a review of how our nation plans to interact with other planets. The issues that we're dealing with are the policies that we have in place that determine what is safe and what isn't when it comes to landing on Mars and other worlds were written, well, in an earlier time when we didn't fully understand all the different places in our solar system that happen to have water. The National Academy of Science, as it reviewed the literature on how we're finding critters pretty much in every ecosystem on Earth, as well as finding water just about everywhere in our solar system. And reviewing that research, realized that NASA has some work to do. Currently, we are trying to define safe ways to get from Earth to Mars with humans and to get from Mars to Earth with rocks. It is fairly certain that the rocks will make it to Earth before the men and women make it to Mars. But whichever way the travel happens, we are running a risk biologically. We don't know for certain if Mars does or doesn't have microbial life. And if we bring back a rock that is carrying a killer virus, a killer bacteria, we could kill off humanity. And that is bad. Probably. So the National Academy of Science is recommending that NASA works to first review the current set of policies and identify where gaps in the policies exist, identify where present policies are out of date when compared to the present science, and then put together a plan for how policies are going to get amended and evolve to take into consideration our current understanding. This particular need is exemplified with the world Europa. This particular icy moon orbiting Jupiter is a target for an upcoming space mission, the Europa Clipper. Originally, the Europa Clipper was set to go out and orbit 45 times and gather detail on this icy world in unprecedented detail as it orbited at fairly low altitudes. NASA, in order to help build up excitement, even went and created travel posters like you see here. And these travel posters paint a picture of a world rife with cephalopods, and other NASA art shows that there could be all manner of life down under the ice, because it's possible for life to cling to hydrothermal vents that probably exist deep in Europa's ocean. So as we look at this little icy world and consider that it might, well, life just might have found a way, as Paranor puts it in the chat, we need to consider how wise is it of us to consider adding a lander to the mission we're planning to send? Is it possible that we are simply going to carry our own Earth bacteria and kill off any life that might already be there and replace it with life from our own world? These are things we need to consider, and the National Science Council here in America, or rather the National Academies of Science here in America, have determined that we don't have the needed policies in place. So sometimes before you leap, you have to study just how deep the pit you're leaping into might be. NASA's looking to make some great leaps to other worlds, and we need to study just what we're getting into before those leaps are made. Now, continuing our story of planetary exploration, in this case, no worlds are in danger. Scientists working to study Uranus out in the edge of our solar system have been running impressive computer models that have, well, within a simulation, hit a younger Uranus over and over and over with synthetic worlds and studied to see just what might happen. Uranus is a rather strange world. It is tilted almost 90 degrees over on its side, such that its north pole points almost exactly at the sun during one part of the year, and its south pole points almost exactly at the sun during another point in the year. This particular orientation has to be the after effect of some sort of an event that changed this particular planet's spin. It also has rings and moons around it and is anomalously cold. Trying to figure out how you tilt a planet, how you freeze a planet, and you build the rings and moons that exist where they exist around this planet has been a challenge, but it appears to be a challenge that has finally been solved. It looks like if you take and you hit Uranus with a glancing blow, so this is one that instead of hitting near the surface, hits near the edge. If you hit Uranus with a 2 Earth mass or larger world with this glancing blow, you can tilt it over on its side. If the object that is making this impact happens to be rich in rocks and ices, it's possible that this material, as it fell into this ice giant, could form a shield and insulation around Uranus's warmer core, preventing heat from escaping to the outer parts of the planetary atmosphere. Additionally, debris that would end up in orbit around Uranus would end up in the same equatorial path as the planet was rotating, and it might be able to even move through gravitational interactions Uranus's previously existing moons to share that same equatorial orbit. Now, to get here, more than 50 different highly complicated simulations had to be made, and this is one of those cases of, well, trying to explain a lot of things using a large computer, and due to not cutting corners and making sure you include all the physics, actually getting at a detailed solution. This is research that's being done at Durham University, and I look forward to following it and seeing just what new things we discover now that we've figured out what the starting parameters are to evolve this world into what we see today. Now, sometimes research raises as many questions as it answers. While this helps us understand how it is that Uranus got tipped on its side, what I'd like to know is, where did that 2 Earth mass remnant end up going? If Uranus was only struck with a glancing blow, that implies that the majority of that impacting world went somewhere. Did it shatter? Is it now making up part of the Kuiper belt? Did it just escape our solar system altogether? These are the things that I'm hoping future research will help us understand. Now, those of you in the southern hemisphere or who have visited the southern hemisphere have perhaps looked up at the constellation Carina and noticed that it is filled with faint fuzzies that you can begin to pick out with a good set of binoculars or a backyard telescope. One of the fuzzies that you can see is this nebula. This is the star, it's actually a binary pair of stars, Eta Carina. During the 1800s, during the 19th century, this object underwent an amazing flare that took it from being not even the brightest star in its particular constellation to being the second brightest object in the entire sky. That particular event led to the formation of the nebula that you see over here. Sorry, I'm pointing the wrong way. And this particular nebula, called the Homunculus Nebula, uh, has been one of those things that has been slow to reveal its mysteries. Initially, we thought there was a single star inside of this nebula, and trying to understand its odd hourglass figure was quite a challenge. This was eventually explained once we launched X-ray and gamma ray telescopes, as there are two high mass stars in this binary system that appear to be orbiting one another. And as they orbit, this pinches off the center of the nebula that thus expanded out. Now, these two massive stars that are roughly 30 and 60 times the mass of our sun actually get extraordinarily close to one another. Their closest point is just a planet's distance away from the particular nebula. Pardon me while I look up the exact numbers to explain this to you a little bit better. Um, oh, my screen is far away. So sorry about that. Um, so we have these two stars, and they orbit every 5.5 years, and the average distance separating the distance that separates them when they are closest together is the same as the average distance between our sun and Mars. So essentially, we have two stars that would dwarf our sun that are orbiting as closely as Mars orbits our sun. That's something kind of amazing to think about. Now, in trying to understand this system, we've long recognized that this high intensity shock wave interacting with the surrounding medium of space has been generating gamma rays. These are extremely high power photons that have the ability to actually break apart strands of DNA in the human body. Our atmosphere luckily protects us from gamma rays, but they are created and studied in laboratories. In addition to producing gamma rays, we knew that this particular nebula and binary star system also produce low power X-rays. These are the kinds of X-rays that we can study with Chandra and XMM Newton. These soft X-rays are more readily focused than the particularly high energy X-rays that fill the gap between the gamma rays that we see with Fermi and the soft X-rays we see with Chandra. Well, in new research that was done looking at this system using new data and archival data spread over many years and more than an orbit of these two stars, scientists have been able to detect the high energy X-rays that are being generated in this system. What's kind of amazing is we see electrons getting accelerated that as they hit the interstellar medium drive the X-rays to be created. These are photons that are created during the collision. These particular high energy particles then head towards, well, all corners of the universe, and some of them reach us here at Earth. Now, this implies that these kinds of high energy particles also have the potential to not necessarily collide with surrounding media and may, in fact, travel all the way to Earth as a source of cosmic rays. So it may just be that some of those high energy particles that we see lighting up the random pixels in our images and lighting up some of our detectors are coming from this particularly bright and amazing star system. It's located about 10,000 light years away, and these two stars could go supernova, one or the other, any minute. Now, general probabilities are that with astronomy, when I say any minute, I mean it could happen today or it could happen 10,000 years from now. We don't know. But I know I am one of many astronomers that hopes to see a supernova locally in my lifetime. So here's to hoping that this source of high energy cosmic rays, X rays, gamma rays, and an amazing nebula keeps producing amazing science that will blow our mind as easily as those gamma rays could blow apart our DNA. So that wraps up the science I had for today. I am now happy to take your questions in the chat. Once again, my name is Dr. Pamela Gay, as it says above me, and this is The Daily Space. The Daily Space is brought to you by CosmoQuest. We are a multi-institution collaboration that invites you to help us explore our universe. Please consider visiting CosmoQuest.org, where you can help us map out other worlds and find the safe places to land a spacecraft and the scientifically interesting places to explore. We are run out of the Astronomical Society of the Pacific and work in collaboration with the Planetary Science Institute and Youngstown State University. We are a nonprofit program, and your subscriptions help sustain us, and every bit really matters. So I'm seeing Fenrig is asking, are contact binaries possible, or is that a myth? Oh, contact binaries totally exist. Contact binaries are two stars that are orbiting closely enough together that the gravitational pull of the stars draws out both stars to be essentially teardrop shaped, and they connect at the center of these, or at the edges of these two teardrops. Over time, contact binaries have the potential to evolve so that you have one particularly large star that has two cores orbiting inside of it. We think this is one of the ways that you get blue stragglers that we see in globular clusters. In addition to contact binaries, we also have a lot of cataclysmic binaries where one star is simply pulling matter off of the other and eating it. So yeah, there's really cool stuff that goes out off in our universe. I agree. Thorn-Zitkov objects do sound like a terrible disease. And I don't actually know that particular name. I'm wondering if it has another name. I'm going to actually Google that real fast. Often things are first named in a rather descriptive way. So a Thorn-Zitkov object is a conjecture type of star within a red giant or supergiant that contains a neutron star at its core, and it formed from the collision of the giant with the neutron star. So these are hypothesized, and there is one known candidate. So this is the kind of thing where collisions are extremely rare, improbable, and so the fact that there's even one candidate is kind of amazing. So Hannes Vorwerp is asking, wouldn't that cause a collapse since a neutron star is not fusing? So what I don't know is if this is a dual core object where you have the neutron star and the stars fusing core orbiting one another, or if this kind of a situation reignites the neutron star, expanding it back out. I just don't know enough about this kind of an object. I do know that Kip Thorne really knows his stuff. And if he says it's possible, it's probably possible. That just doesn't mean it's probable. Those are two different things. So Larry is asking, can contact or near contact binaries form planets from their interactions? There are earlier hypotheses that our solar system formed this way that was discredited. So the problem with trying to form something out of contact binaries is contact binaries are still gravitationally bound objects. They are bound to each other gravitationally, and their atmospheres are bound within this crazy touching teardrop shape. The idea that significant mass can get strewn out that is more than just hydrogen and high energy particles that are getting blown off through stellar winds is highly improbable. So just like we don't see objects forming out of the material that gets blown off of our sun, it's moving, it's dispersing, it periodically causes really pretty northern lights. This particular material doesn't recoalesce to form planets. So Hannes Vorwerp is asking, do super large stars have super large sunspots, or are they covered with normal sized ones? So Hanny, the sunspots that we see are actually proportional to a star's magnetic field. So we get bigger sunspots when we have bigger, stronger magnetic fields. The question then becomes, are there big stars with big magnetic fields? And there are, but not all big stars have big magnetic fields, and not all small stars have small magnetic fields. This means that we end up with, in the vast diversity of stars, we end up with all sizes of magnetic fields on all sizes of stars, more or less. And this means that we see large stars on large objects, and we see large spots on large and small objects. So yes, not sure if I explained that well. I was trying to keep up with what was going on in the chat. I hope that helped. The universe is more complicated than anything our human minds are capable of coming up with on their own. Science is far more fascinating than science fiction sometimes, and I absolutely adore science fiction. Okay, so what other questions do you have? And Paranor's making a really good point there, Peter. Oh, Fenrig, hurry. I may not be here much longer. I have a meeting in 5 minutes. Okay, do we have any more questions? Other than we're apparently timing how quickly Fenring can run. So yes, you can catch all of our shows up on YouTube. I'm going to be working to make sure that everything gets uploaded with notes on these stories starting this week. And please feel free to, uh, well, share our links. Noel is commenting that Mars Mappers has become very difficult. Yes, we switched what area on Mars that we're looking at. Our science team is currently trying to understand volcanism on Mars, and so the areas that you're looking at will have more craters and fewer sand dunes than what we've seen so far. So Fem Stranger is asking, so what is the largest sunspot recorded? I don't actually know that. What I do know is quite often sunspots are as large or larger in diameter than planets, and that is just kind of amazing. Um, so I don't know, but big. Big is the answer. Um, okay. So uh any other questions out there? And I promise no one is going to be able to take over the show. They just might be slightly annoying in chat. So um it's all good. Noel, I'm sure you can do precision circle drawing. Oh, that's awesome, Paranor. Yeah, folks, in general, I strongly recommend spaceweather.com as a fabulous source to go to find out what's going on above our atmosphere, to track when there's going to be amazing aurora, and other things that go flash and boom in the night. Um, Big J, the meeting starts in 3 minutes, so um, there will be more people in 3 minutes, I suspect. Um, so we have our general CosmoQuest meeting for staff in 3 minutes. So Peter, you don't need to worry about this one. Um, any final questions? So uh, I have to thank you all for coming once again. We will be having another stream this evening when I will be back at 9 p.m. Eastern, which is 6 p.m. Pacific, which is 11 a.m. tomorrow in Sydney, Australia. I am going to be working on doing some data visualizations. I'm currently working on trying to create a somewhat realistic orbiting hot Jupiter snuggled up right next to a star. This is a model of the Kelp 9b system. So hopefully I'll see some of you this evening. And if not, we will be continuing the daily show tomorrow. This is a holiday that isn't going to stop the science. So tune in again on Wednesday at 1 p.m. Eastern, 6 p.m. London, 10 a.m. Pacific, and get your daily dose of all that's new in astronomy and space science. Once again, this is a project of CosmoQuest, and we invite you to help us learn and discover our solar system. Please join us at cosmoquest.org. We have a particular need for Mars and Mercury data at the moment. If you want to sustain this show, please consider a subscription, and remember, every bit helps. So thanks a lot, everyone, for coming. And I hope to see you all around the internets. Bye-bye.